uh, in today's video we're gonna be focusing on what we call U-substitution and also definite integrals. Definite integrals and also indefinite ones that we have done some of them in the previous video. Okay, firstly, here is a recap of what we have done. On the previous video we have done infinite integrals, we have done the power rule, which was like this, yes, this was the power rule, which was used to integrate functions, which was used to integrate polynomials. But then now here is the question: what is it that you're gonna do when you find something like this? What will you do? Okay, here is where the U-substitution gonna take place. Okay, here is where the U-substitution gonna take place. Okay, now let's firstly try to elaborate a bit. What is U-substitution? U-substitution, which is normally called the U-sub. Okay, let me tell you about this. It is a technique or a trick that is used to simplify okanye to change complex integrand and make them very easy. To simplify complex or very difficult complex integrands and make them easy to solve. Yes, this is why we use this. Then it has its conditions, but I'm not gonna list them all here, more especially when dealing with trigonometric functions. Okay, now let's quickly solve this. Let's firstly check the space. Okay, we can solve the first one. Solution. Here is the solution. Okay, here we have 0, we have 1, we have 2x, then we have x squared plus 9 cubed dx. Here we are required to integrate this function, this with respect to x, and we cannot use the power rule. So what is it that we can do? Okay, the power rule here enters. So now let's take a look. Okay, here we have 2x, here we have x squared. If you remember back the chain rule, take the derivative of the inside and the derivative of the outside, and all those we used the U-substitution when doing the chain rules in derivative and stuff. So here we're going to make the inside function, we're going to make this part of the function equals to u. So u is equals to x squared plus 9. So u is equals to this. So okay, this means this is the integral of this from 0 to 1. So yes, from 0 to 1, 2x of, we have u here, this is equals to u, so we're going to substitute that with the u cubed dx. But because we are changing this function, all of this function, we want it to be in terms of u so that we can easily integrate it. So we also need to change this because we cannot integrate u in terms of x. We cannot integrate u with respect to x. We need to integrate u with respect to u. So how can we change this dx? Okay, this is what we know, is that dx, if we derive this this function of u with respect to x, okay, let's do that before I explain it. Let's derive this function with respect to x. Du with respect to x is equals to, what is the derivative of this? The derivative of this with respect to x is equals to 2x. So now let's solve for dx now. Let's find out what dx is equals to. So we're going to multiply by dx, so that this and this divides each other. So we're left with du equals to 2 dx. But what is dx equals to? Now if we divide by 2x both sides, we are going to get du over 2x equals to dx. So we can substitute dx by du, so that we have the integral of 0 to 1, 2x u cubed. Instead of dx, we are going to put in this du over 2x, du over 2x. Then automatically this and this divides each other, so that you are left with 0 to 1 u cubed du. So now you see, now we are only left with this u. Now we are integrating the function of u with respect to u. Okay, now we can go ahead and integrate this using that rule, which is the power rule. So as we know that it's going to be u to the u cubed plus 1 all divided by 3 plus 1. But then now, because it's no longer a definite integral. Oh, okay, wait. Let's fix here. But I don't think it really matters in this case, because both our limits are constants. So because both my limits are constant, no, this is what we do. Now. We need to change this function. So that we don't do something that we're not sure of. Let's convert this function and make it be in terms of x again. Let's make it be in terms of x. So far, let's get rid of this a bit. Then we check. Yes, then we check. I will confirm this in no time. So let's substitute back our x values. Let's substitute back our x values here. But if I was okay, we're gonna do that on the other page. I will repeat this problem again here with you. So taking this back, we're going to have u to the 4th over 4, which is equals to x squared plus 9 to the 4th over 4. Yes, but then because of these limits, which are 0 and 1, we are integrating x equals to 0 from x equals to 0 to x equals to 1. Okay, let's copy this here. We have something like, we have x squared plus 9 to the power of 4 to the power of 4 all divided by 4 from x equals to 0 to x equals to 1. Okay, now so this will have to subtract this, so this is equals to, we're going to substitute these limits here. So the upper limit will go first. The upper limit will subtract the lower limit. Upper limit minus the lower limit. This is how this works. So we're going to have, instead of x, we're going to substitute 1 squared plus 9 to the power of 4 all divided by 4 minus, instead of x, we're going to substitute 0 minus 0 squared plus 9 all to the power of 4 all divided by 4. So this and this gives us 10 to the power of 4 divided by 4 minus this will be 9 to the power of 4 divided by 4. Then you punch that on your calculator.